Hello students, Jai Swaminarayan. I am Professor Urvish Mewada, HOD Electrical Department, Sri Swaminarayan Institute of Technology, Bhat, Gandhinagar. I am the subject matter of Industrial Instrumentation subject, which is in the 7th semester Electrical, and GTU subject code for this subject is 2170913. Students, we are currently discussing the chapter number 3, Displacement Measurement. In Displacement Measurement, today we have on the topic number 10 and lecture number 3. In last lecture we have discussed about the shaft encoder and various type of shaft encoder that we use for the displacement measurement, and resolvers means for the measurement with its application, advantages, disadvantages, and the proximity sensors. So today we are having the topic number 10, that is synchros. So let us discuss how synchros work for the displacement measurement. Now the synchros basically transform the angular position of the shaft of into an electric signal. So basically we use here synchronous machine to transform the angular position into the electrical signal. So so it is used as an error detector and as a rotary position sensor. So such kind of we can say application is available generally for the displacement measurement is say rotary position sensor. Now when the error occurs in the system because of the misalignment of the shaft, the transmitter and the control transformer are the two main parts of the synchros. So when the error occurs at that time, then the motor, or we can say the synchronous machine, will change the position of the shaft according to the error detection. Means whatever the error is, we can say, into the output, according to that the error, the output of the means the other machine which is synchronized with the synchronous machine will change its position. So this is just this is the transform the angular position of the shaft into the electrical signal, and that can be measured in terms of electrical output. That's why this synchros means it's a transducer which transform the angular position into the electrical output. Basically transmitter and control transformer are the two main types of the synchros. So the synchro system of say having two types, synchro system types. First is torque transmission type, and second one is control type. So let us discuss the first one, that is torque transmission type synchro. Now uh, in this type of synchro has the small output because whatever the torque generated due to the error is very small, and hence they are used for running the very light load like pointer, or we can say control type of synchros is used for the driving the loads. So here the torque transmission type synchros having the output, say it is minimum, or we can say very low, so that the application of this torque type transmission type synchros is to just operate the pointers, or we can say the light loads which are connected to the shaft. Now for the control type synchros is used to driving the large loads. So here the control synchros is used for the error detection in positional control system. So here we use the synchronous machine structure or construction for the detection of the position of the shaft, and that system consists of two units. There are first is synchro transmitter and the synchro receiver. Now in this we have the first type, that is synchro transmitter. So in the synchro transmitter, this is the structure of the means transmitter. So this is a structure like a synchronous machine. In this you can see that we have the rotor. In rotor we have applied the alternating supply, and this is rotor coil on here to the rotor coil means field winding of this pole, or we can say rotor, we applied the AC supply. And this is these three are the stator conductor, and the stator conductor are 120 degree aparted to each other, means electrically they are 120 degree aparted to each other. And for the input, or if we want to give the input to the field winding of this rotor, we require the slip rings, because this portion is rotary and this outer portion is stationary. That's why it is called stator, and inner portion is called the rotor. Now the stator winding is say is means slotted due to means into the inner surface of the stator. We have the teeth and slot structure, in which we have the stator winding, and this winding is say means three different winding 120 degree aparted to each other. So whatever the flux produced means the if we give the field current to this rotor coil, then the flux will produce that flux will cut by the stator conductor, and stator conductor will produce the EMF. Now synchro transmitter, that construction is say similar to the three-phase alternator. The stator of the synchros is made of steel. Yes, we know that the core is made up of basically steel, means silicon steel or dynamo steel material, so that we can reduce the hysteresis loss of the machine, and so that we can reduce the iron losses of the machine. And the stator is slotted, as I discussed, that stator is having teeth and slot structure, so it say provide housing to the stator winding, and the axis of the stator winding is kept 120 degree apart from the each other. So from that, if we rotate this rotor, we will get three-phase output. Now the AC voltage is applied to the rotor of the transmitter, and it is expressed as VR, means this is the rotor voltage, so it is under root 2 sine omega CT, where VR is the RMS value, or we can say the supply which is applied to the rotor circuit, so RMS value of the rotor voltage, and WC means omega C is the carrier frequency of the rotation. Now here sorry now here this is the structure of say synchro transmitter. So the coils of the stator windings are connected to the star, so this is the star connection. This is the shape which is forming the star connection, and the rotor of the synchronous is say dumbbell in shape, so it is look like a dumbbell. That's why it is also called the salient pole machine, and a concentric coil is wound on it. So the coil which is wounded on the rotor circuit is called rotor field winding, and the AC voltage is applied to the rotor with the help of slip rings. So generally we use slip rings to give supply to the motor which having the rotary part. So generally the rotary part rotates, and the on the slip ring we put the carbon brush, and through the carbon brush we can give the supply. Now the constructional feature of the synchros which are shown in this diagram. So over here you can see that this is the rotation of the rotor having the angle theta r, and this is the angle that is 240 plus theta r. So the angle which is acquired over here, from over here to here, 120 plus 120, it is 240 plus theta r. So that's why 240 plus theta r. R1 and R2 are the two terminals of the rotor field winding. S1, S2 and S3 are three coils of the stator, and this three are the terminal at which we are getting the output for of the synchro transmitter. Now here we are considering the voltage is applied to the rotor, means over here we are giving the supply, and of the transmitter which is shown in this diagram. So here we use two different structure of synchro transmitter and synchronous transmitter and control transformer. So here we have three winding. This is means this two having very far distance, because this type of error correction generally system is applied for the say hydropower station for the door opening and closing from the remote station. So such kind of technology can be used for the for very far station. So this is not we can say both are nearer to each other, they are having very far distance between them. Now this is the synchro transmitter that we already seen. So this is the router of the synchronous transmitter on which or we can say on which we have the rotor field winding, and the two terminals of the rotors are R2 and R1, and the AC supply that we are giving. So as this AC supply we are giving over here, so this is the theta R. If the rotor rotates, it will take the angle from the initial position theta R. So S1, S2 and S3 are the three terminals of the synchro transmitter. Now this both are connected in parallel. So here S2 is connected with S2, S3 is connected with S3, and S1 is connected with S1. Now this is the position of the rotor. You can see that this is the vertical position, and the rotor of this control transformer is say at horizontal position. So both are if we superimpose these two rotor, then the difference between these two rotor positions are position is 90 degree. So this is the stator coil of control transformer. S2 is connected with S2, S3 is connected with S3, and S1 is connected with S1, and this is the rotor on which again this as the field winding is applied or means wounded this rotor. So the over here the rotor is also wounded with the rotor conductor, or we can say rotor field winding, and theta c is the angle acquired by the control transformer once it receives the error signal from the synchro transmitter. So this is what this setup is means a working function of the synchro error detector. So let us discuss the voltage applied to the rotor induced in the magnetizing current and the alternating flux along it. Matlab means whatever the voltage applied, according to the voltage applied, the rotor induce the magnetizing current, and the alternating flux will produce, and this alternating flux will cut by the stator conductor. So the voltage is induced in the stator winding due to the cutting action of magnetic lines of force, and because of the mutual induction between the rotor and stator flux, the flux linked in the stator winding means the flux which transfer through the air gap, and then after it will link to the stator conductor, and the flux which is linked to the stator winding is equal to the cosine of the angle between the rotor and stator. So whatever the angle take by the stator circuit and rotor circuit, that will be the cosine angle between the rotor and stator. So the voltage is induced in the stator winding. So here whatever the voltage induced in the stator winding, that will be Vs1, Vs2 and Vs3, because it is generating in the stator winding, that's why it is indicated as S1, S2 and S3, and the voltage generated in the stator winding S1, S2 and S3 are respectively. So these are the voltage that is generated in the three winding, and the figure that we shows the rotor position of the synchro transmitter. Now the rotor axis makes an angle theta r. So here the rotor angle, as the rotor angle making the angle theta r, so that is concerned with the stator winding S2. So sorry, S1, S2 and S3. So we can write the equation for Vs1 to n. So that will be k vr sine omega c t cos theta r plus 120. So this is the position of the rotor once we apply the means electrical supply to the synchro transmitter. So the angle means sine and cosine angle between that two is theta r plus 120. So here you can write this Vs2n for this is Vs1n and this is Vs2n. So Vs2n is kVr sin omega c t cos omega theta r. So theta r is the second position, that's why this is Vs2. So Vs1n is equal to kVr sin omega c t cos theta r plus 240. So here the initial angle is 0, then 120, then 240. So this is the additional angle that acquired by the rotor circuit once we give the supply to the stator winding. Now here Now, as we know that the function of the synchro is the to convert angular position into the voltage, or we can say electrical output. So the three terminals of the stator winding are Vs1 S2 is equal to Vs1n minus Vs2n. Now we substitute the value of this two, then we'll get Vs1 S2. So that is root 3 kVAR sin theta r plus 240 sin omega ct, and Vs3 to Vs3s2 will be Vs2n minus Vs3n. So here when we put this value, so we'll get the Vs1s2, that is root 3 kVAR sin theta r plus 120 sin omega ct. So Vs3s1, now these three are the possibilities of the voltage when we rotate the synchro transmitter rotor, and according to the rotation of the rotor, the EMF will produce, and that will receive by the stator conductor, and that stator conductor will give output to the synchro control transformer, means synchro control transformer. So Vs3 S1 is the Vs3n minus Vs1n, so that will be Vs3 S1 is equal to kVR sin omega ct sin theta r. So here is the angle difference between each of the voltage that will be the next position of the rotor while we after we give the supply to the synchro transmitter. Now the variation in the stator terminal is axis concerning the rotor is shown in the figure. So the as we discussed the previous diagram, the ET over here you can see that ET, or we can say EF, that we are getting over here. So terminal voltage that we get at the rotor side, stator side of the synchro controller, that is K dash VR cos 90 minus theta r plus theta c. So this will be the angle of the rotor position of the control transformer. So that's why it is 90 minus theta r plus theta c sin omega ct. So ET will be K dash VR sin theta r minus theta c. So this is the output voltage, or we can say the output which we get once we give once the transmitted voltage converted into the rotor position, and rotor position is converted into the electrical output. So how this electrical output we can get from the synchro transmitter? So synchro transmitter and synchro receiver both are the say synchronous machine, and according to the field current applied to the rotor circuit of the synchro transmitter will produce the EMF and flux. That flux will transfer through the means air gap, and then after that flux interact with the stator conductor, so that the EMF will produce in the stator conductor. Now whatever the amount of rotation we give to the synchro transmitter, according to that rotation EMF will produce in the stator conductor, and whatever the EMF produced in the stator conductor, that EMF will travel to the synchro control transformer, and whatever the amount of EMF given to the stator winding of the control transformer, according to that that supply, the flux will produce in the stator conductor, and the flux which is produced in the stator conductor, and the supply which is already applied to the rotor winding, due to the resultant of this that too, the rotor of the control transformer will generate the torque, and according to the generated output of the synchro transmitter, the rotor will take the position, and that will be 90 degree always ahead to the synchro transmitter rotor position. Now when the rotor angle becomes 0, the maximum current is produced in the stator winding S2, and the 0 position of the rotor is used as reference for the determining the rotor angular position, and the output of the transmitter is given to stator winding of the control transformer, that I already discussed. This is the explanation which I already discussed with you. And the current of the same magnitude flow through the transmitter and control transformer of the synchros. And according to this, the current which is transferred through this means whatever the current which we give into the input of the control sorry the synchro transmitter, according to that current and voltage will receive by the control transformer at the receiving station. So because of the circulating current, the flux is established between the air gap flux of the control transformer, and so that the flux axis is controlled of the control transformer, and the transmitter is aligned in the same position, and the voltage generated by the rotor of the control transformer is equal to the cosine angle between the rotor of the transmitter and the controller. So whatever the amount of voltage that we get at the rotor output, that will be the means just because of the voltage that which are coming as the form of error voltage, and according to that means magnitude of that voltage, the EMF will produce in the synchro controller transformer. So this is the voltage that we receive is Et is equal to K dash Vr cos theta sin omega Ct. So this will be the output of the synchro receiver, or we can say control transformer, synchro control transformer. Now where psi is the angular displacement between the rotor axis of the transmitter and the controller, and theta is 90 theta sorry phi is 90 the axis between the rotor and transmitter, rotor of the transmitter and the control transformer is perpendicular to each other. So this is what we discuss in the diagram of this synchro transmitter and the control transformer, synchro control transformer. Now the diagram that shown in this is the error, or we can say position control system that we discussed after this. So the diagram which shows the zero position of the rotor of the transmitter and receiver. So consider the position of the rotor and the transmitter is changing in the same direction. Now angle theta r deflects the rotor of the transmitter, and that of the control transformer is kept the theta c. So this theta c indicates this is the control transformer angle, and theta r is the control means transmitter synchro transmitter angle, rotor angle. So the separation, or we can say angular separation between the rotor total phi is equal to 90 minus theta r plus theta c, that we already discussed, and the rotor terminal voltage Et is K dash Vr cos 90 theta r plus theta c sin omega t c, that is already discussed. Now Et will be K dash Vr sin 90 sin cos 90 will be sin theta r minus theta c sin omega c t. So the small angular displacement between the rotor position is given by theta is equal to sin theta r minus theta c. So this will be the displacement that we get in terms of angular position. So on substituting the value of the angular displacement, we get Et is equal to K dash Vr cos phi sin omega Ct. So this will be the output voltage that is generated at the synchro control transformer. Now over here, this is the diagram which shows this is the load which is driven with the help of say synchro control transformer. So whatever the position of means according to the position of the synchro control transmitter, this synchro control receiver will receive the means input over here in the S2 S3 S2 and S2 S1 S2 and S3, and whatever the flux produced, according to that flux, this will this rotor will means change its position, and so that the load which is connected to this will rotates, and this is the gearing mechanism that is applied to this synchro control transformer. So over here the AC amplification, whatever the AC supply which is generated over here, the amplification of this AC voltage will be increased, or the change means that can be changed with the help of AC amplification unit. So this gearing mechanism will provide the rotation, and according to the rotation of this exciter will get the input, and that will be amplified, and according to the amplified output this load will rotate. So this is how the position control system, or we can say synchro control transmitter and receiver works. So in this and this is the working function of the position control system. So in the position control system, generally we require this kind of large setup, and the position of the synchro control transformer that we can control means from the very far end, and that is from the synchro control transmitter. So as I already explained you, such kind of applications are means application of this position control system is used for the door opening and closing of the hydropower station. Now the synchro transmitter and the control transformer together use the detecting the error. So the voltage equation shown above is equal to the sharp position of this the rotor of the control transformer and the transmitter. So here, from here we control the position of this rotor. According to the movement of this rotor, the EMF will produce in this conductor, and the voltage will transfer through this conducting wires, and then after this through this coil, the current which is passing through means voltage and current which are say induced in this will pass through this windings, and so that this winding will produce the flux, and this because it is wounded on the stator core, so stator core will produce the flux, and that flux will interact with the synchro control transformer rotor, so that in this rotor the EMF will produce due to the cutting action of magnetic lines of force, and whatever the EMF will produce over here, it is not capable, so AC amplification is required. So this is with the help of exciter or gearing mechanism, we provide the AC amplification, and according to that amplified voltage the load will be driven over here. So this is the working function of the position control system, and in this position control system, generally it can be more easily seen by this three graphs. So this is the first graph that indicates the angle the difference between the rotor means synchro transmitter rotor angle, and this is the control rotor angle. So theta r minus theta c that we already derived. So this is the waveform of the theta r minus theta c, and this is the voltage that we are applying. So root 2 VR sin omega ct. So when we superimpose this 2, will get EM at t ks theta r minus theta c. So this will be the resultant voltage. So the modulating wave means shows the misalignment between the rotor position and the carrier wave. So from that we can calculate the modulated EMF for output. So T is equal to Ks minus theta r minus theta c. So where Ks is equal to error detector factor. So this is how we can means detect the error using synchros and synchro transmitter. Such kind of theories asked in the GTU essay. This is the very important theory of this chapter, and this kind of theory is repeatedly asked in the GTU exam. So please refer it again, and try to solve your doubts related to this theory. Now after this we have the assignment question is explain synchro transmitter in detail. The related instructions of this assignment is written below. Please read it carefully. You can take the snap of this slide, and this is the last topic of this chapter. In this after this we will discuss the chapter number 4, force measurement. So if you have any doubt or any query related to this topic, feel free to ask me, or if you can have the doubt, then we can solve your doubts in our doubt solving session. So thank you very much student. Thank you all. Jai Swaminarayan.